All right, evaluate a logarithm. I think for the students that were in my class last semester, most of you know that after I show how they do this in the book, I'm going to show you how you do it in the calculator anyways. But we should be at least proficient enough to be able to do what I'm about to do. It's not that hard. What they would expect us to do to evaluate a logarithm of a base that does not appear, at least on the front of your calculator, it's not there, is first step would be set it equal to x. Okay? It's something that we don't know what it is as we start the problem. Second step, convert it to an exponential. Right? 8 to the x equals 16. Now, when they give us these problems, they always give numbers that should be fairly easily recognized as being powers of some smaller number, the same base on either side, like 8 and 16 are both powers of 2. Right? It wouldn't work if this was like 8 and that was 27. Then this thing really wouldn't work. We need to be able to say that both of these could be represented as powers of the same base. And really, the way it goes most of the time, it'll be 2 or 3. It can't get too much bigger, or else the numbers just get too big. So 8 is 2 to the third. 16 is 2 to the fourth. So you would have to recognize that. 2 to the third to the x. 2 to the fourth. Okay, now how do we simplify powers of x, properties of exponents? When you raise a power to a power, what's the operation between them? To multiply, remember? We did the add. That was different. That's when you're multiplying 10 to the fourth times 10 to the fifth. That's when you add the exponents. When you raise a power to a power, you multiply. So that's 2 to the 3x. Okay. Now we've got exponentials on both sides, and the base of the exponential is the same. So it must be, this is called a one-to-one property. It must be that the exponents are the same. If the left-hand side equals the right-hand side, and the bases are the same, then 3x equals 4. And x equals 4/3. 1.333333, right? Now, like I said, in fact, when we started doing this, there's this thing, and then there's the graphs of logarithms of any base. That up to a certain point in time, our calculator only had the logarithms that you see on the front, log, L-O-G, and right underneath, ln. But actually, these 84s, they have log of any base in them. So we probably, if you got a question like this on the SOL, I would definitely put it in the calculator. If you remember, in the calculator, where do you find the log of any base? You go into the math, and then you go all the way down to the bottom where it says log base. Arrow up. Okay? So now it's giving us a place to enter a different base. So we can enter in the 8. What is this? Log base 8 is 16. 8. And then I can arrow over to that, 16. And hit enter. And now we'll say, in order to turn that back into a fraction, I'll go map, enter, enter, 4/3. So that's the same answer as that right there.